Hi everyone and Assalamualaikum warahmatullahi wabarakatuh. My name is Nur binti Muhammad Amin and metric number is I191-03637. Now let's get started to chapter 4, Ethical and Social Issues in Information Systems. I'm going to talk about 4.4, how have information systems affected laws for establishing accountability and liability and the quality of everyday life. Firstly, I'm going to present about computer-related liability problems. In general, it is very difficult to hold software producers liable for their software products that are considered to be like books, regardless of the physical or economic harm that result. Historically, print publishers of books and periodicals have not been held liable because of fears that liability claims would interfere with First Amendment rights guaranteeing freedom of expression. The kind of harm software failures cause is rarely fatal and typically inconveniences users but does not physically harm them. What about software as a service? ATMs are a service provided to bank customers. If this service fails, customers will be inconvenienced and perhaps harmed economically if they cannot access their funds in a timely manner. Should liability protection be extended to software publishers and operators of defective financial, accounting, simulation, or marketing systems? Software is very different from books. Software users may develop expectations of infallibility about software. Software is less easily inspected than a book and it is more difficult to compare with other software products for quality. Next, telephone systems have not been held liable for the messages transmitted because they are regulated common carriers. In return for their right to provide telephone service, they must provide access to all at reasonable rates and achieve acceptable reliability. Likewise, cable networks are considered private networks, not subject to regulation, but broadcasters using the public airwave are subject to a wide variety of federal and local constraints on content and facilities. The next thing I will share with you is system quality, which is data quality and system errors. The debate over liability and accountability for unintentional consequences of system use raises a related but independent moral dimension. What is an acceptable, technologically feasible level of system quality? At what point should system managers say, "Stop testing, we have done all we can to perfect this software, let's go live"? Individuals and organizations may be held responsible for avoidable and foreseeable consequences, which they have a duty to perceive and correct. For example, although software companies try to debug their products before releasing them to the marketplace, they knowingly ship buggy products because the time and cost of fixing all minor errors would prevent these products from ever being released. What if the product was not offered on the marketplace? And would social welfare as a whole falter and perhaps even decline? Carrying this further, just what is the responsibility of a producer of computer services? Should it withdraw the product that can never be perfect, warn the user, or forget about the risk? Although software bugs and facility catastrophes are likely to be widely reported in the press, by far the most common source of business system failure is data quality. Few companies routinely measure the quality of their data, but individual organizations report data error rates ranging from 0.5 to 30%. As you see, there are three principal sources of poor system performance. Firstly, software bugs and errors. Second, hardware or facility failures caused by natural or other causes. Third, poor input data quality. Quality of life, equity, access, and boundaries. The negative social costs of introducing information technologies and systems are beginning to mount along with the power of the technology. Many of these negative social consequences are not violations of individual rights or property crimes. Nevertheless, they can be extremely harmful to individuals, societies, and political institutions. Computers and information technologies potentially can destroy valuable elements of our culture and society, even while they bring us benefits. Next, negative social consequences of systems. Balancing power, center versus periphery. Although computing power decentralizing, key decision-making remains centralized. Coupled with an ideology of empowerment of Twitter and social media users and the decentralization of decision-making to lower organizational levels, up until recently reduced the fears of power centralization in government institutions. Rapidity of change, reduced response time to competition. Businesses may not have enough time to respond to global competition. To this, more efficient global marketplace has reduced the normal social buffers that permitted businesses many years to adjust to competition. Maintaining boundaries, family, work, and leisure. Computing, internet use lengthen work day, infringes on family, personal time. Parts of this book were produced on trains and planes as well as on vacations and during what otherwise might have been family time. Although authors have traditionally worked just about anywhere, the advent of information systems coupled with the growth of knowledge work occupations means that more and more people are working when traditionally they would have been playing or communicating with family and friends. Next, dependence and vulnerability. Public and private organizations ever more dependent on computer systems. Computer crime and abuse. Computer crime, commission of illegal acts through use of computer or against a computer systems. Computer abuse, unethical acts, not illegal. Employment, trickle-down technology and re-engineering job loss. Re-engineering work resulting in lost jobs. Equity and access, increasing racial and social class cleavage. Certain ethnic and income groups in the United States less likely to have computers or internet access. Okay, by the end of this presentation, you will be able to know about health risks. Firstly, repetitive stress injury, RSI. RSI occurs when muscle groups are forced through repetitive actions, often with high impact loads, such as tennis or tests of thousands of repetitions under low impact loads, such as working at a computer keyboard. Second, carpal tunnel syndrome, CTS, in which pressure on the median nerve through the wrist bony structure, called a carpal tunnel, produces pain. And lastly, computer vision syndrome, CVS, which refers to any eye strain condition related to display screen use in desktop computers, laptops, e-readers, smartphones, and handheld video games. CVS affects about 90% of people who spend 3 hours or more per day at a computer. Its symptoms, which are usually temporary, include headache, blurred vision, and dry and irritated eyes. Okay, thank you for listening. I hope you will understand what I explained just now. Assalamualaikum warahmatullahi wabarakatuh and bye.